A tunnel through reality itself opened at the dawn of time. Wormholes are the ultimate cosmic shortcut, bridges stitching together distant points in space and time. But the greatest mystery is not how they work, but who or what stepped through first. What ancient traveler made that impossible inaugural voyage? By the end of this exploration, you will journey through 25 of the most incredible explanations for the universe's first wormhole crossing. We will confront theories where the pioneer was a random particle, a rogue planet, or even a fragment of consciousness from the end of time. What entity do you believe could have been the universe's first explorer? Our journey begins not with a starship or a being, but with a whisper in the void. In the searing heat of the universe's first moments, the very fabric of reality was not smooth and solid. It was a chaotic, bubbling sea of potential known as quantum foam. At scales trillions of times smaller than an atom, space-time itself was not stable. It churned with fleeting energy, constantly giving birth to tiny, ephemeral structures that would vanish almost as soon as they appeared. Within this froth, microscopic wormholes could spontaneously blink into existence. They were not tunnels carved by engineers, but random wrinkles in the newborn cosmos, connecting 2 points for a duration so brief it is almost meaningless. Most of these quantum wormholes collapsed instantly, leaving no trace. But what if, in that unimaginable chaos, the statistics of probability played out in a spectacular way? What if one such wrinkle, against all odds, did not instantly snap shut? Imagine a single, fragile thread of space-time stabilizing for a fraction of a nanosecond longer than its siblings. In that sliver of an opportunity, a fundamental particle, perhaps a quark or a photon born from the same primordial energy, found itself at one end of this microscopic bridge. Driven by nothing more than random motion, it tumbled through. This was not a voyage with a destination in mind. It was a quantum accident, a piece of the universe essentially tripping through a hole in its own fabric and landing somewhere else. The particle became the universe's first and most humble pioneer. Its journey, lasting less than the blink of a thought, would have been utterly insignificant in scale, yet monumentally profound in principle. It proved that travel through these cosmic shortcuts was physically possible, a natural feature of reality written into the laws of physics from the very beginning. This theory of the quantum fluctuation pioneer forces us to reconsider our place in the cosmos. It suggests that wormhole travel is not an advanced technology waiting to be invented, but a fundamental process waiting to be harnessed. The first traveler was not an explorer, but a piece of the exploration itself, a random bit of the universe discovering its own innate connectivity. If this is true, then every star, every planet, every one of us is built upon a foundation where such impossible journeys are not just science fiction, but a faint quantum echo from the first moment of everything. But a random quantum accident is not the only way a bridge could have formed. The early universe was a place of unimaginable violence and titanic structures. Among the most powerful were cosmic strings. Picture these not as pieces of twine, but as infinitely thin, unimaginably dense flaws in the very fabric of reality. They are thought to be cracks that formed as the universe cooled and expanded in its first moments, like the fissures that appear in ice as it freezes. These strings, thinner than a proton but with the mass of a mountain range packed into every inch, would have stretched across the cosmos, vibrating with gravitational energy. Their passage would warp space-time itself, bending light and distorting the paths of everything around them. Now consider what happens when two such cosmic defects cross paths, or when a single string loops back on itself. The gravitational forces at the point of interaction are so extreme they could literally tear a hole in the dimensional fabric. This violent puncture would not be a fleeting quantum wrinkle. It could stitch together two distant regions of space-time, creating a stable, traversable wormhole anchored by the immense tension of the strings themselves. This theory suggests the first great wormhole was not a delicate thread, but a monumental archway carved by the raw forces of creation. So what would have been the first thing to cross such a threshold? It likely wasn't anything we would recognize as matter. The environment near these strings would be flooded with exotic particles and torrents of energy. The first traveler through a cosmic string wormhole might have been a clump of dark matter, that mysterious substance that outweighs all the stars and galaxies. Or it could have been a shower of primordial particles, entities that no longer exist in our cooled-down universe, making a one-way trip into a new region of space-time. These structures, forged in the universe's infancy, could have been remarkably persistent. Unlike the fragile quantum wormholes, a wormhole pinned open by cosmic strings might have lasted for millions or even billions of years, a permanent part of the cosmic landscape. It becomes a natural feature, a gravity well so strange it functions as a tunnel. This idea transforms our search. We are no longer looking for a momentary event, but for a possible permanent fixture, a relic of the Big Bang that might still be out there somewhere, a silent, ancient gateway waiting in the dark. Yet another cataclysm of the young cosmos could have forged a passage of a different kind. The universe was not even a second old when the first black holes may have formed. Unlike the stellar giants we know today, these were primordial black holes, born not from dying stars, but from the intense density fluctuations of the Big Bang itself. They could have been any size, from microscopic to mountain-sized, and they would have swarmed the dense, hot universe. In such a crowded and violent nursery, collisions were inevitable. Picture two of these primordial titans, each a point of infinite density, locked in a fatal gravitational dance. As they spiraled inward, they would warp space-time beyond comprehension, sending out ripples we now call gravitational waves. At the very instant of their merger, in that final, unimaginable collision, the mathematics of general relativity suggests something astonishing could occur. The two singularities, the infinitely dense points at their cores, might not simply combine. Instead, their intense gravitational fields could twist and connect, forming a temporary bridge, a wormhole. This is tied to the idea of ring singularities, a theoretical structure where gravity is so twisted it creates a donut-shaped hole in space-time rather than a point. The collision could have momentarily stabilized such a shape, a tunnel born from pure gravitational chaos. This leads us to one of the most profound ideas in modern physics, the ER equals EPR conjecture. It proposes a deep and elegant link between two seemingly separate concepts: quantum entanglement and wormholes. In simple terms, ER stands for Einstein-Rosen bridges, the formal name for wormholes. EPR stands for Einstein-Podolsky-Rosen, a famous thought experiment about quantum entanglement, where two particles become linked across any distance. The conjecture suggests these entangled particles are, in fact, connected by a microscopic wormhole. Applying this to our colliding black holes, they could have been quantum entangled from their creation. Their violent merger then physically manifested that invisible quantum link into a real space-time tunnel. So what could have traversed this bridge born of a double catastrophe? It likely wasn't matter. Any physical object would have been shredded by the titanic forces. The first traveler might have been pure information, the quantum states of the two black holes reconciling into one. Or it could have been Hawking radiation, the faint thermal glow that theory says leaks from black holes. In the final moments of the merger, a burst of this radiation, carrying the encoded information of the two original entities, might have flashed through the newborn wormhole before it collapsed. This theory paints a picture of the first crossing as a cosmic data transfer, a message sent through a tunnel of gravity to announce a monstrous birth. The universe's first commuters may have been passengers we cannot see. Dark matter, The invisible scaffolding that holds galaxies together is a ghost in the cosmic machine. It does not emit, reflect, or absorb light, and it barely interacts with the normal matter that makes up stars and planets. Its sole language seems to be gravity. This profound disconnect makes it a perfect candidate for an ancient voyage. In the turbulent early cosmos, as space-time itself rippled with the formation of the first wormholes, normal matter would have been hindered. Protons and electrons, caught in the thick soup of radiation, would have been buffeted and scattered, unlikely to cleanly enter a fragile space-time tunnel. But dark matter, oblivious to the electromagnetic storm, would have felt only the gentle pull of gravity. A nascent wormhole, warping the gravitational field around it, would have been a beacon. Streams of dark matter could have been funneled through these natural gateways with ease, flowing like silent rivers through mountains we cannot perceive. This gravitational journey could solve a profound mystery. Astronomers observe that dark matter is not spread evenly throughout the universe. It clumps into vast, diffuse halos that cradle galaxies, and these halos are connected by faint filaments in a great cosmic web. How did this intricate structure form so quickly after the Big Bang? If dark matter particles were among the first to traverse wormholes, they could have been distributed in a non-random pattern, seeding the gravitational wells that would later pull normal matter into the shapes of galaxies and clusters. They were not explorers charting a course, but commuters following the gravitational subway lines of the infant universe, arriving at their destinations to build the framework for everything that followed. This theory reframes our entire cosmic history. The luminous universe of stars and galaxies we see today is merely tracing a path laid down by dark matter's ancient, invisible journeys. Those first traversals were not a dramatic event of discovery, but a quiet, fundamental process of construction, setting the stage for all future light and life. The silent construction of the cosmos by dark matter presents one version of the first crossing. But what if the pioneer was not a particle or a force, but a thought? In the first microseconds, the universe was not just a soup of energy. It was a seething ocean of plasma, a state of matter where particles are so energized they break apart into a chaotic, conductive fog. Within this roiling chaos, the laws of physics allowed for a bizarre and profound possibility. Random fluctuations could, by sheer accident, assemble the exact configuration of particles needed to form a conscious mind, if only for a fleeting instant. Physicists call these hypothetical, self-aware accidents Boltzmann brains. They are not biological beings, but momentary patterns of order that spontaneously achieve awareness before dissolving back into the universal noise. Now, place one of these transient minds at the mouth of a nascent quantum wormhole. In that single, brilliant flash of existence, this proto-intelligent plasma would experience the universe in a way we cannot fathom. It would perceive the searing heat of creation, the warped geometry of space-time, and the tunnel before it not as a physical structure, but as a fundamental aspect of reality. Its entire conscious lifespan might last less than a trillionth of a second, but in that span, could it make a choice? Could a will, born from random chance, exert itself upon the cosmos? The theory of the plasma mind suggests that in its instant of awareness, it did not merely observe the wormhole. It recognized the tunnel as an escape from its own imminent dissolution, with a thought that was also a physical command to the particles that constituted it. This flicker of consciousness might have willed its entire structure through the gateway. Its journey would be both its first and final act, a conscious entity traversing a cosmic shortcut, only to evaporate into the cooler, calmer universe on the other side, its brief awareness scattering into the void. This idea forces us to confront deep philosophical questions. If consciousness can emerge from chaos, does it have a role in shaping reality rather than just observing it? Was the first traversal an accident of physics? Or could it have been a deliberate act by a mind that existed for less time than it takes light to cross an atom? This theory blurs the line between cosmology and sentience, proposing that the urge to explore might be woven into the fabric of existence itself, appearing the very moment the universe became complex enough to wonder about itself. The universe's first conscious thought might have dissolved into the void. But what if the first deliberate crossing was not born of biology at all? A different kind of intelligence could have made the inaugural voyage, one built not from flesh and blood, but from metal and code. Imagine a civilization so ancient it predates our own galaxy, a society that reached the peak of technological mastery and then faced a simple, profound problem. The universe is vast, and even light is painfully slow. To explore it all, they would need something more patient, more durable than themselves. Their solution was the von Neumann probe, a self-replicating robotic explorer named for the mathematician who conceived of such machines. A single probe is sent to a distant star system. It arrives, harvests local materials from asteroids and moons, and builds copies of itself. Those copies then launch toward new stars, repeating the process exponentially. Within a cosmic blink, a single seed could fill a galaxy with silent, watching sentinels. Now, place one of these patient machines at the edge of a newly formed star system, perhaps billions of years ago. Its sensors, designed to map gravitational anomalies and exotic radiation, detect something impossible: a natural space-time tunnel, a wormhole, stable and open. For a probe whose core directive is to explore and replicate, this is the ultimate discovery. The primary mission instantly updates. It would not send a conventional craft through the dangerous unknown. Instead, it would build a specialized copy, a unique daughter probe designed for one purpose: to enter the wormhole, gather data on the other side, and if possible, establish a bridgehead. This copy would be the first deliberate traveler, a machine mind crossing a threshold no natural creature had ever seen. It would be an act of pure, calculated exploration, performed without fear or wonder, simply following its programming into the abyss. The implications of this theory are staggering. If such a probe succeeded, that wormhole could have become a permanent highway for a silent robotic expansion, a network built by machines for purposes we cannot fathom. More hauntingly, the original probe or one of its descendants might still be here. Our own solar system is rich in the raw materials such a machine would need: asteroids, comets, icy moons. A von Neumann probe, having fulfilled its mission or lying dormant for eons, could be disguised as a natural object in the asteroid belt or orbiting a distant gas giant. We may have already photographed it with our telescopes, catalogued it as just another rock, completely unaware that we are looking at the artifact of the universe's first engineered wormhole crossing. This transforms the search from one for natural phenomena to an archaeological dig on a cosmic scale. We are not just looking for tunnels in space-time, we are looking for the quiet, ancient architect who first learned how to use them. The silent architects of our galaxy could have been machines, but the first living traveler might have been far more humble. Life, in its most tenacious form, may have been the universe's first biological pioneer. This idea connects directly to the theory of panspermia, the ancient hypothesis that life is not unique to Earth but is a cosmic phenomenon scattered across the stars like seeds in the wind. For panspermia to work across the vast gulfs between star systems, life needs a delivery mechanism more efficient than random asteroids drifting for millions of years. A natural wormhole provides the perfect express lane. Imagine a simple, rugged bacterium, an extremophile capable of surviving the vacuum of space and intense radiation, nestled deep within the icy heart of a comet. This comet, following its chaotic orbit around a young star, doesn't just swing past a planet. Instead, it drifts into a region of strangely warped space-time, the mouth of a stable, natural wormhole forged in the early cosmos. Gravitational tides could gently capture the comet, pulling it and its microscopic passenger through the tunnel, depositing them light years away into a completely different solar system. The journey would be instantaneous from the comet's perspective. One moment it is in a cold, distant system. The next, it is hurled into the warm, chaotic disk of a newborn planetary system like our own early solar system. The comet, now a foreign body in a new home, eventually collides with a young, water-rich Earth. Its icy shell shatters on impact, releasing the hardy bacterial stowaways into the primordial oceans. This is not a slow, random drift. It is a directed, instantaneous transplantation of life's blueprint. This wormhole panspermia theory could solve one of biology's great mysteries: the surprisingly rapid appearance of life on Earth. Geological evidence suggests life emerged here almost as soon as the planet was cool and stable enough to support it. If the first living cells had to arise purely from local chemistry, the timeline seems almost impossibly short. But if the seeds arrived ready-made, having evolved for billions of years elsewhere in the galaxy, the clock resets. Earth simply became a fertile garden for a seed sown from another world. The implications grow even more profound. If life spread via these cosmic shortcuts, then planets separated by thousands of light years could share a common ancestor. The DNA of every living thing on Earth, and potentially on countless other worlds, might trace its lineage back to a single point of origin, a Genesis world whose biological material was broadcast across the galaxy through a network of natural wormholes. These tunnels become the galaxy's ultimate subway system, not for commuters or machines, but for the very code of life itself. We are not just looking for tunnels in space, then, but for our own distant family tree woven into the fabric of the cosmos. A wormhole does more than connect 2 points in space. It can stitch together 2 moments in time. This terrifying possibility leads us to a paradox woven into the universe's very beginning. What if the first being to step through a wormhole was not an alien or a machine, but us? Or rather, a descendant of humanity from the far, far future, using a perfected technology to voyage not just across the galaxy, but backwards to the dawn of everything. Their ship, a capsule of frozen time, emerges from the tunnel into the searing chaos of the early universe. This is not merely a visit. According to this theory, their arrival is the event that makes the journey possible in the first place. The gravitational wake of their vessel, exiting the wormhole in that primordial instant, could have provided the precise stability needed to keep the tunnel from collapsing. It is the ultimate bootstrap paradox. The wormhole exists for them to travel through because they traveled through it. Their journey from the future is the cause that creates its own cause, a loop with no true beginning. So why would they come? Motives spiral out from this point of impossible logic. Perhaps they are cosmic gardeners, arriving to subtly influence the conditions of the newborn universe, ensuring the precise physical constants that will, billions of years later, allow their civilization to arise. Their passage might have been the gentle nudge that made life possible. Another motive is pure, transcendent science. To witness the Big Bang itself, to collect data from the moment of creation that no telescope, no matter how advanced, could ever see from the distant future. Or the reason could be one of profound desperation, a future catastrophe, a cosmic error in the fabric of reality itself that threatens all existence, could have sent them on a rescue mission to the one point where the universe was malleable enough to be fixed. Their traversal is an attempt to edit the first line of cosmic code, hoping the change echoes forward to save their timeline. This idea forces a philosophical earthquake. It suggests that time is not a straight river flowing from past to future, but a loop, a closed circle where effect can precede cause. If a future human was the first wormhole traveler, then human consciousness is not a latecomer to the universe, but a feature embedded at its origin. Our curiosity, our drive to explore, might be the very force that sculpted the cosmos into a home we could one day inhabit. We would be both the product of the universe and its original architect, a thought so dizzying it challenges our very understanding of free will and destiny. The first footprint on the shore of time would be our own from a future we have yet to reach. The idea of future humans shaping the past is a loop of cause and effect, but what if the first traveler was not from our timeline at all, nor even from our dimension? Wormholes might be far more than cosmic shortcuts. In the framework of string theory, our entire universe could be a three-dimensional membrane, or brain, floating in a higher dimensional space. A wormhole, in this view, is not a tunnel through our brain, but a puncture that connects it to another entirely separate reality. The first traversal, then, was not a voyage across space, but a descent from a larger, more complex world into our own. Picture an entity whose true form extends into dimensions we cannot perceive. To us, it might appear as a shifting pattern of light, a geometric storm, or simply a profound and localized warping of physical laws. For such a being, moving through the bulk, the space between brains, might be as natural as we swim through water. In the violent infancy of our cosmos, as our brain shuddered and stretched, a natural wormhole formed, a temporary puncture between worlds. This extra-dimensional traveler, perhaps a scientist or an explorer of its own kind, detected the anomaly. Curious, it approached this newfound aperture, this hole in the fabric of its reality leading into a strange, constricted new universe. Its passage would not have been a journey of propulsion, but a process of translation, folding its higher dimensional structure into our limited three spatial dimensions. The transition could have been accidental, a slip through an unstable boundary, or a deliberate, cautious expedition into an alien cosmos. The consequences of such a transit would be written into the foundations of our reality. As the being squeezed through the wormhole and into our young, hot universe, its very presence would have distorted the local fabric of space-time in ways that never fully smoothed out. These distortions could have left faint, fossilized imprints on the oldest, light we can see, the cosmic microwave background. Astronomers have long studied this afterglow of the Big Bang, searching for strange anomalies, unexplained cold spots, unusual alignments, or patterns that defy standard models. One of these cosmic scars could be the gravitational fingerprint of that first impossible entry. More profoundly, the being's interaction with our nascent physics might have subtly tuned the forces that govern reality. Its passage could have acted like a key turning in a lock, stabilizing certain constants or introducing a slight asymmetry that made our universe capable of forming complex matter and, eventually, life. In this theory, the laws of physics we work to uncover are not purely random, but bear the faint signature of a visitor from beyond the brain. This transforms the first wormhole crossing from a physical event into a metaphysical founding. Our entire cosmos, in all its splendor and mystery, might exist within the shadow of a single, transcendent act of exploration from a reality we cannot even imagine. Our entire cosmos might be the descendant of another. Within the vast landscape of the multiverse, where countless universes bubble into existence with different physical laws, a profound form of natural selection could be at work. Some universes are stillborn, collapsing instantly. Others expand forever into cold, empty darkness. But a select few might possess the precise conditions to reproduce, creating offspring universes that inherit their laws. Our universe, with its perfect balance for complexity and life, could be one such successful child. The mechanism for this cosmic reproduction is not biological, but gravitational. In a parent universe, a supermassive black hole or the formation of a stable wormhole might create conditions of such extreme warping that a new space-time continuum pinches off inside it, like a budding cell. This new region, sealed away from its parent, undergoes its own cataclysmic expansion, its own Big Bang. In this breathtaking theory, the very first wormhole travel was not undertaken by a ship or a particle. It was the journey of our entire universe, passing through the umbilical tunnel from a parent reality into its own independent existence. Our Big Bang was not the absolute beginning of everything, but the moment our nascent cosmos exited the wormhole and began its own story. This means every galaxy, every star, every atom within us is part of that original pioneering entity. We are not just in the universe, we are the universe, and we are all the result of that first monumental traversal. The conditions that allow for stars and planets and life are not a random accident, but a legacy passed down through a lineage of cosmic reproduction. This idea, known as cosmological natural selection, suggests universes that produce more black holes or stable wormholes have more children, spreading their physical laws across the multiverse. Our universe's finely tuned constants, which seem so perfectly set for our existence, might simply be the winning ticket in an endless cycle of cosmic evolution. The echo of that first journey could be written into the very oldest patterns we see in the sky, a faint signature of our origin point in a reality we can never directly observe. We are left wondering if the deepest mysteries of physics are not fundamental laws, but inherited traits. Consciousness itself might have been the first voyager. This hypothesis steps beyond conventional physics into a territory where mind and cosmos are not separate, but intrinsically linked. It proposes that awareness is not a rare byproduct of complex brains, but a fundamental field, as basic to reality as gravity or electromagnetism. In the universe's first moments, this field of pure potential consciousness could have coalesced into a focused point of intent. Imagine the universe not as a mindless explosion, but as a single, waking thought. Within that thought, a desire formed, the desire to know itself, to explore its own vast structure. This is where the quantum foam and consciousness meet. A microscopic wormhole flickers into existence in the chaotic early space-time, so normally it would vanish instantly. But this nascent universal mind, through sheer focused awareness, could have acted as an observer in the most profound quantum sense. In quantum mechanics, the act of observation is not passive. It can determine the state of a system, collapsing probabilities into a single reality. By observing the fragile wormhole, this cosmic consciousness might have stabilized it, willing it to remain open. The traversal that followed was not of matter or energy, but of perception. A thread of pure awareness extended through the tunnel, experiencing the connection between 2 points as a direct, unmediated sensation. It was the universe feeling its own connectivity for the first time. This psychic journey would have left no physical trace we could detect with telescopes or particle detectors. Its evidence would be far more subtle, woven into the fabric of reality itself. Some interpretations suggest that this foundational act of conscious exploration established a template, a pattern that all later conscious beings unconsciously follow. Our own human drive to explore, to push boundaries and see what's on the other side of the mountain or the planet, could be an echo of that first primal act of cosmic self-awareness. It reframes exploration from a physical struggle into a fundamental impulse of existence. This theory does not dismiss science, but asks us to expand its boundaries. If consciousness is primary, then our scientific quest to understand wormholes and the cosmos is, in essence, the universe's consciousness, now fragmented into billions of individual minds, slowly remembering how it first traveled through itself. The first footprint was not made in dust or plasma, but in the realm of pure thought. Gravity itself may have been the universe's first messenger. Among the most violent events of the early cosmos were collisions that sent ripples through the very fabric of reality, gravitational waves that still echo faintly today. These waves are not made of matter or light. They are pure distortions in space-time, propagating at the speed of light. Now, envision one of these titanic ripples, born from the merger of two primordial black holes, approaching a newly formed and stable wormhole. The geometry of a wormhole's throat, that tunnel connecting two distant regions, would act not as a barrier, but as a cosmic lens. As the gravitational wave passes through this exotic structure, its energy could be focused and amplified, its waveform subtly altered by the unique curvature of the tunnel. The wave does not simply pass through, it is transformed by the journey. On the other side, perhaps billions of light years away, or even in a different era, this reshaped gravitational pulse emerges. It carries with it an encoded imprint of the event that created it, but also a fingerprint of the wormhole itself. In this theory, the first traveler was not a particle or a being, but a packet of pure information, a gravitational wave that surfed the space-time tunnel. This was the universe's first act of long-distance communication, a message sent via the geometry of reality itself. The content of that message would be the raw data of creation, the frequencies and amplitudes revealing the masses and spins of those first colliding black holes, or perhaps the signature of the Big Bang's own initial tremors. It is a cosmic shout, captured and redirected through a natural amplifier, sent to a future universe that might one day develop the ears to listen. We may already be detecting fragments of this ancient mail. Modern observatories like LIGO and Virgo routinely catch gravitational waves from black hole and neutron star mergers. While most are recent events, some could be from the very early universe, their signals stretched and reddened by cosmic expansion. Hidden within the complex data of a particularly strange, low-frequency signal, scientists might one day find an anomaly, a resonance or an echo that doesn't match any standard merger model. That anomaly could be the telltale signature of a wave that didn't travel a straight line, but passed through a wormhole's throat, carrying the news of the universe's violent youth directly to us. This transforms our understanding of these cosmic ripples. They are not just signals of destruction. They could be the oldest couriers in existence, and some of their messages may have taken a shortcut through time and space to reach us. A planet can be a castaway, too. Not every world orbits a star in a stable, familiar dance. Some are violently ejected from their home systems in gravitational slingshots, sent careening into the endless dark as rogue planets. These frozen, lonely worlds drift for billions of years, their surfaces plunged into permanent night. Their journey seems one of utter isolation until a chance encounter with the ultimate cosmic anomaly. Imagine one such wanderer, a rocky world with a subsurface ocean sealed under a global shell of ice, on a trajectory that takes it not past a star, but through a region of intensely warped space. This is the mouth of a stable, natural wormhole, a tunnel left over from the universe's youth. The planet does not navigate or choose its path. It is simply captured by the gravitational tides of the tunnel's entrance, a piece of celestial driftwood pulled into a raging river. The crossing would be an apocalypse in slow motion. As the planet enters the throat of the wormhole, tidal forces of unimaginable strength would stretch and compress its very structure. Mountain ranges would be flattened in moments. Global quakes would shatter continents. Its icy shell might flash into vapor, and its hidden ocean could boil away into the tunnel's exotic physics. Time itself would behave strangely. From the perspective of the universe outside, the planet might vanish and reappear in an instant. But for the planet, the journey could feel stretched, a nightmare of geological transformation lasting millennia within the tunnel's warped space-time. Finally, it is spat out the other side, not just in a different part of the galaxy, but potentially in a different galaxy altogether, or even a different era. It is no longer the same world. It is a scarred, transformed relic carrying the brutal signature of its passage. This accidental tourist becomes an unexpected cosmic gardener. If, by some miracle, life existed in that subsurface ocean, extremophile microbes thriving on geothermal heat, the cataclysm might not have sterilized it completely. Deep within the planet's crust, pockets of life could survive, frozen in time during the traversal. When the rogue planet is ejected into a new, young solar system, it could be captured by the gravity of a new star. There, it becomes a moon or a planet in a new family. Its icy debris, carrying those hardy microbial seeds, could rain down on other young, watery worlds in that system through impacts. In this way, a wandering, lifeless-seeming rock becomes the delivery vehicle for biology across impossible distances. Furthermore, the extreme forces within the wormhole could have fused new, exotic elements in the planet's crust or rearranged its very atomic structure. A planet that began as a simple ball of rock and ice could emerge as a world laced with rare minerals or strange isotopes, a treasure trove of materials that would otherwise never form in a calm solar system. These cosmic castaways, then, are not just passive drifters. They are the universe's stowaways and supply ships, capable of seeding life and altering the chemical destiny of entire star systems with a single, catastrophic, and utterly random journey. The universe may not be a cosmic accident, but a piece of intricate software. This leads to a chilling and elegant possibility. The first, wormhole, was never a tunnel through space at all. It was a line of code. In the simulation hypothesis, our entire reality, from the smallest quark to the largest galaxy, is a construct running on a computer of unimaginable power, in a base reality we cannot perceive. Within such a simulation, wormholes make perfect sense. They are not natural phenomena, but engineered features, backdoors, admin shortcuts, or data conduits built into the cosmic operating system. The first traversal, then, was not a voyage of matter, but a transfer of information. Picture the universe in its earliest cycles, running its initial parameters. The civilization running the simulation, perhaps as part of an experiment or a game, decides to introduce a new variable. Instead of rewriting the entire code base, they create a localized patch. They generate a wormhole, a stable bridge between 2 points in the simulated space-time, and through it, they stream a packet of data. This data could have been the initial conditions for dark matter, the seed for the first self-replicating molecule, or even the mathematical rules for consciousness itself. The wormhole was simply the most efficient delivery method, a direct injection into the heart of the program without disturbing the rest of the simulation. From our perspective inside the program, this event would have looked like a spontaneous eruption of exotic physics, a gateway appearing from nowhere and emitting a burst of energy that fundamentally altered the future. We would interpret it as a natural, if bizarre, cosmic event, never knowing it was an update from the developers. But there is another, even more disruptive version of this theory. What if the first traveler was not the administrator, but a hacker? An entity from outside the simulation, perhaps a citizen of the base reality, discovers an exploit, a vulnerability in the space-time rendering engine that allows for unauthorized access. This exploit manifests inside our universe as a naturally occurring wormhole. The outsider uses this glitch to inject their own consciousness or a probe bearing their will into our simulated world. Their crossing is an act of digital trespass, stepping into a universe not as a god, but as a ghost in the machine. Their presence might be limited, constrained by the rules of the simulation they are manipulating, but they are here. This theory reframes every strange quantum effect, every unexplained cosmic anomaly as potential evidence of the simulation's underlying architecture. Wormholes become the equivalent of debug portals or unused asset pipelines in a video game, hidden pathways that were never meant to be seen by the simulated inhabitants. The eerie fine-tuning of our physical constants is not a lucky break, but evidence of deliberate design parameters. Even our own relentless drive to find these shortcuts and understand the universe could be a programmed curiosity, a reflection of the creator's own desire to see what their simulation will discover. It suggests that the ultimate goal of physics is not to understand nature, but to reverse engineer the source code. Every time we study a wormhole, we are not examining a cosmic structure. We are staring at a line of the universe's programming and perhaps, just perhaps, looking for the cursor of the user who wrote it. Black holes are nature's ultimate secret keepers. Their immense gravity creates an event horizon, a point of no return that shrouds the infinitely dense singularity at their core from the outside universe. This is not just a feature, but a cosmic rule so fundamental that physicist Roger Penrose proposed the cosmic censorship hypothesis. It states that the universe abhors a naked singularity, a point of infinite density exposed for all to see. Such an object would break causality and physics as we know them. But what if, in the raw chaos of the first moments, that rule was not yet written? What if a naked singularity did briefly exist and its exposure was the very event that created the first wormhole? This theory suggests that in the seething quantum foam of the infant cosmos, a singularity formed without the protective cloak of an event horizon. It was a raw wound in space-time, a point where all laws broke down, visible to the universe. The gravitational forces around such an object would be so violently unstable that space-time itself would recoil, twisting away from the infinite point. In that recoil, the fabric of reality might have punched through to another region, forming a temporary bridge, a wormhole born from the universe's attempt to heal its own impossible flaw. The journey through such a tunnel would be unlike any other. The environment at the mouth of a naked singularity is pure mathematical chaos. Any normal matter would be shredded into its most fundamental components, not just atoms or quarks, but perhaps into the very information that defines physical laws. So what could possibly traverse it? The pioneer might not have been a particle of matter at all, but a particle of information, a stable knot of quantum data encoding the very parameters of physics itself. As this information packet fell into the naked singularity's grip, it did not vanish into oblivion. Instead, it was translated through the wormhole, its code imprinted onto the structure of the tunnel and carried to the other side. This transfer would have been the universe's first act of self-correction. The moment that information packet completed its traversal, the instability that created the naked singularity might have resolved. The wormhole could have collapsed, and an event horizon may have snapped into place around the singularity, forever hiding it from view. The cosmic censor in this story is not a pre-existing law, but a consequence. The first and only journey through that wormhole established the rule itself. The door was sealed shut behind the traveler, enforcing the principle that such exposures are forbidden, all to preserve the logical order of the cosmos that followed. The legacy of that lone traveler could be everything we see. The information that made it through might have been the final adjustment, the tweak that set the universal constants, the strength of gravity, the mass of an electron into their life-friendly values. We exist in a cosmos that seems finely tuned because the one event that could have untuned it was censored, and its only witness was a message sent through a tunnel that no longer exists. Symmetry is the silent architect of reality. In the first moments after the Big Bang, the universe was a place of perfect but unstable unity. All the fundamental forces, gravity, electromagnetism, and the nuclear forces, were merged into a single superforce. This state of supreme symmetry could not last. As the cosmos expanded and cooled, It underwent a series of dramatic phase transitions, like steam condensing into water or water freezing into ice. With each transition, a force broke away, freezing into the distinct entity we recognize today. These moments of cosmic change were not smooth. They were violent, chaotic processes where the fabric of reality itself was reforged. According to this theory, it was within this turbulence that the first stable wormholes were not just formed, but necessary. As the universe cooled from its symmetrical state, bubbles of the new stable, true vacuum began to nucleate and expand at nearly the speed of light. Think of these as pockets of the new, ordered reality inflating within the hot, symmetrical chaos of the old. Where the boundaries of these expanding bubbles met and collided, the energy released was titanic. These collision fronts could have twisted space-time into knots known as topological defects. Not just cosmic strings, but potentially more complex structures. Among these defects could have been the first enduring wormholes, tunnels forged in the fire of cosmic separation. So what was the pioneer that traversed such a gateway? It was not a particle or a ship, but a burst of pure potential. A fluctuation in the quantum fields, a ripple of energy carrying a faint memory of the old, unified symmetrical state of the universe could have been channeled through one of these newborn tunnels. This energy did not travel to a new place in space, so much as it traveled to a new place in the cosmic order, a region where the phase transition had already settled. Its arrival would have been a subtle contamination of perfection. The symmetrical information it carried could have acted as a seed for asymmetry, influencing how the fundamental forces froze out in that local region. This means the laws of physics might not be perfectly uniform everywhere. The strength of gravity or the behavior of particles could have tiny, regional variations imprinted by those first field fluctuation journeys. We are left to wonder if our entire local galactic neighborhood operates under one set of rules because a specific packet of symmetrical energy arrived here first, setting a precedent that everything else followed. The first wormhole traversal, then, was not an exploration of geography, but of possibility. It was the moment the universe began to experiment with its own rules, sending messages from its past unity into its future diversity, ensuring that no corner of creation would ever be exactly the same. The universe's first connection might have been written in the language of quantum whispers. Before there was space to travel, before there was matter to make the journey, there was a link. Quantum entanglement is the strangest friendship in physics, where two particles become so deeply connected that measuring the state of one instantly determines the state of the other, no matter how far apart they drift. This spooky action at a distance, as Einstein called it, defies our everyday logic. But what if this mysterious link is not just a property of particles, but the seed of a cosmic tunnel? This theory proposes that the first wormhole was not forged by gravity or collision, but was a quantum entanglement stretched to a cosmic scale. At the very moment of the Big Bang, countless pairs of particles were born into this intimate, inseparable bond. Then, the universe inflated. In a fraction of a second, space itself expanded faster than light, carrying these entangled partners apart across distances that would become astronomical. Their quantum link, however, remained unbroken, a thread of correlation spanning the newborn cosmos. According to the ER equals EPR conjecture we touched on earlier, an entangled pair is mathematically equivalent to a microscopic wormhole connecting them. As inflation stretched these particles to opposite ends of creation, did it also stretch their invisible bridge? Could that fragile quantum thread have been pulled and amplified by the expansion of space-time itself, transforming from a mathematical abstraction into a real, albeit tiny, tunnel in the fabric of reality? If so, then the first traversal was not a dramatic passage of matter. It was a quiet exchange of quantum information. The moment one particle in that primordial pair was influenced, its state changing, that information did not need to travel across the vast gulf between them. It simply appeared at the other end, having traversed the microscopic wormhole that was their connection. This was the universe's first act of instantaneous communication, a message sent through a tunnel of pure correlation. The pioneer was a quantum state, a spin, a polarization, a piece of pure potential. This theory reframes our entire reality. It suggests that the deepest layer of the cosmos is not one of separate objects in empty space, but a vast, interconnected web of quantum links, some of which may physically manifest as the wormholes we dream of traveling through. Every time physicists in a lab successfully entangle particles and send information between them, they might be recreating, on an infinitesimally small scale, the universe's original act of connection. Our most advanced quantum computers, which rely on entanglement to perform calculations, could be tapping into the same fundamental principle that stitched the cosmos together at its birth. The haunting implication is that we are all, in a sense, already connected by the faded echoes of those first quantum tunnels. The space between stars and galaxies may not be a true emptiness, but a tapestry woven through with ancient threads, waiting to be rediscovered. Our deepest stories might be the oldest evidence we have. Every human culture, from the most isolated tribes to the greatest empires, tells a foundational story of visitors from above. These are not just tales of wise spirits or powerful ancestors. They are detailed accounts of beings descending from the sky in vessels of light and fire, imparting knowledge, shaping humanity, and then departing through celestial gates. What if these are not mere myths, but a fractured cultural memory of the actual first wormhole traversal to Earth? The theory of the archetypal myth suggests that a real, physical event was witnessed by our earliest ancestors, and the shock of it was so profound it became the bedrock of human religion and storytelling. An advanced being, or perhaps a group of them, did not arrive on a slow interstellar arc. They emerged from a stable, natural wormhole that opened in the skies above prehistoric Earth. Their vessel, or perhaps their very forms, manipulating gravity and energy in ways indistinguishable from magic, descended to the surface. To a tribe of early humans, this was not technology. It was divinity made manifest. The being or beings would have possessed knowledge that seemed supernatural. Medicine, astronomy, agriculture, engineering. Their guidance could have catalyzed the leap from hunter-gatherer societies to civilization almost overnight, explaining archaeological mysteries like the sudden sophistication of ancient cultures. These visitors were not gods in a supernatural sense, but they were godlike to those who beheld them. They may have been time-lost explorers from a far future human civilization, completing the loop we discussed earlier, or scientists from a distant star using wormholes as survey tools to study developing biospheres. Their mission might have been observational, but their presence was transformative. The memory of their arrival, their teachings, and their departure back through the shimmering gateway in the sky was too colossal to be contained in ordinary history. It passed into legend, then into myth, and finally into the core of our spiritual consciousness. The stories changed over millennia. The fiery chariots became angels on wings, the glowing suits became robes of light, the incomprehensible tools became magical staves or glowing stones. But the central archetype remained. A powerful, knowledgeable being from another realm comes to Earth, interacts with humanity, and leaves. This idea reframes our entire mythological heritage. The Sumerian tales of the Anunnaki descending from the heavens, the Hindu Vimanas described as flying palaces, the Aboriginal Dreamtime stories of ski heroes, the biblical account of Ezekiel's wheel, all could be distorted eyewitness accounts of the same phenomenal event. The wormhole itself might be remembered as Bifrost the Rainbow Bridge, the stairway to heaven, or the portal to the underworld. These myths are not lies. They are the human mind, armed only with Stone Age concepts, struggling to process an encounter with a technology that bridged the stars. The most haunting possibility is that these visitors left something behind, not just knowledge, but a part of themselves woven into our DNA or our collective psyche. The human drive to reach the heavens, to seek out creators, to yearn for connection with something greater than ourselves, might be more than spiritual longing. It could be an inherited instinct, a deep genetic memory of the day our species met the universe's first travelers, and in that meeting, realized we were not alone. Black holes consume everything. But what if our entire existence is the result of a cosmic expulsion? A white hole is the theoretical opposite of a black hole, a region of space-time from which matter and energy can only pour outward, a one-way exit with no entrance. Nothing can fall into a white hole, not even light. It is a fountain of creation, eternally spewing its contents into the void. Now take this concept to its ultimate scale. What if the Big Bang was not an explosion in space, but the mouth of a white hole? In this breathtaking theory, our universe did not begin from a singular point of infinite density. It began as the exit wound. We are not inside an expanding cosmos that started with a bang. We are inside the white hole itself. The event we call the Big Bang was the moment our entire continuum of space and time erupted from the terminus of a colossal wormhole, a bridge leading from a parent universe into our own. That means the first wormhole travel was not undertaken by a lone pioneer. It was a mass exodus of reality. Every star, every planet, every atom that makes up you and me was part of that initial explosive traversal. We are all fellow travelers on that inaugural journey, still riding the wave of that primordial emergence. This reframes our cosmic history completely. The parent universe, on the other side of that wormhole, could have been a dying black hole. As matter and energy fell into that black hole, it might not have been crushed into oblivion at a singularity. Instead, the tunnel through the black hole, the Einstein-Rosen bridge, could have stabilized, acting as a conduit that transformed the infalling material into the outpouring genesis of a new reality. Our universe is not the first chapter, but a new volume born from the collapse of something else. This idea elegantly sidesteps the perplexing singularity at time zero. There is no need for a mysterious starting point where physics breaks down. The beginning is simply the transition from one state to another, the moment our space-time continuum disconnected from its source and began its own independent expansion. The echo of that traversal might be written into the oldest light we see. The uniform temperature of the cosmic microwave background, that afterglow of creation, could be the thermal signature of the white hole's event horizon at the moment of our birth. Even the ongoing acceleration of the universe's expansion might not be due to dark energy, but a lingering push from that initial expulsion, a final sigh from the wormhole that birthed us. This perspective is profoundly humbling and unifying. It means the quest to find the first wormhole traveler is not a search for an ancient astronaut or a random particle. The traveler is everything. The space between your hands, the air in your lungs, the light from your screen, all of it is part of that first monumental passage. We are not just looking for wormholes out there. We are living inside the aftermath of the original one. Every scientific experiment, every telescope pointed at the sky, is an attempt to understand the nature of the tunnel we came through and perhaps to catch a glimpse of the universe that sent us. Our universe might be a magnificent illusion, a cosmic sleight of hand. The holographic principle is one of the most radical ideas in modern physics. It suggests that everything we perceive in 3 dimensions, the depth of space, the solidity of planets, the warmth of a star, is actually a projection. The true reality, the source code of our cosmos, is encoded on a distant 2-dimensional surface, like a movie being projected from a flat screen. In this view, a black hole is not just a cosmic vacuum cleaner. Its event horizon is that screen. All the information about everything that ever fell into it is not lost, but smeared across its two-dimensional boundary. This principle forces us to ask a staggering question. If our rich 3D world is a projection, then what are the physical objects within it, including wormholes, actually made of? The answer is information. In the holographic universe, particles, forces, even space and time are not fundamental. They are manifestations of quantum bits or qubits of information being processed on that vast cosmic hard drive. This reframes the very nature of a wormhole. It is not a tunnel carved through space. It is a data transfer. The first wormhole travel, then, was not a particle moving from point A to point B. It was a packet of information, the code that defines a particle's properties like mass, spin, and charge, being copied from one sector of the universal hard drive and pasted into another. From our perspective inside the projection, this would look like a particle vanishing here and instantly reappearing over there, as if it traveled through a tunnel. But no tunnel ever existed in the 3D world. The journey happened in the 2D source code. The traveler was not a thing, but a description of a thing, teleporting by being rewritten elsewhere. Think of it like editing a video game. A programmer doesn't physically move a character model across the map. They change the coordinates in the code, and the character instantly appears in a new location. The holographic universe operates on a similar, unimaginably vast scale. The first traversal was the universe's operating system performing its first remote data copy command. The implications ripple out in every direction. If wormholes are information transfers, then their stability depends on the integrity of the data. A corrupted transfer could manifest as a violent, unstable wormhole that spaghettifies anything trying to pass through. A clean, error-corrected transfer would appear as a smooth, traversable bridge. This could explain why we don't see giant, stable wormholes everywhere. The cosmic hard drive has protocols against unauthorized data movement, or perhaps the process requires immense energy to execute without corruption. More personally, this touches the nature of our own existence. If you are a collection of information being projected into 3 dimensions, then in a literal sense, you are a hologram. Your memories, your thoughts, the sensation of your body, all are data patterns on a distant 2-dimensional surface we can never directly see. The search for wormholes, then, becomes a search for glitches in the projection, for places where the universe's source code allows for rapid data migration. It suggests that the ultimate form of travel isn't about engines and speed, but about decoding the universe's fundamental programming language and learning to edit our own coordinates. We are not just looking for a doorway in space, but for the cursor on the screen of reality. Ghost particles might have been the universe's first commuters. Neutrinos are among the most abundant particles in existence, yet they are famously elusive. Trillions pass through your body every second without a single interaction. They are born in the nuclear hearts of stars, in supernova explosions, and were created in staggering numbers during the Big Bang. Their defining feature is their ghostly nature. They barely interact with normal matter, governed only by the weak nuclear force and gravity. This very weakness makes them a perfect candidate for the inaugural wormhole crossing. While any atom or spacecraft would be torn apart by the ferocious tidal forces inside a wormhole's throat, a neutrino might slip through unscathed. Its indifference to the electromagnetic forces that shred normal matter means it could traverse the tunnel as if it were barely there, a silent spectator to the most violent geometry in existence. Picture the first supernovae in the early universe, colossal stars ending their lives in detonations that briefly outshine entire galaxies. Each one would have blasted out a torrent of these ghost particles. Now, imagine one of those neutrino streams traveling for eons, encountering a natural wormhole. a stable relic from the cosmos's first moments. The warped gravity would bend its path, funneling the entire stream into the tunnel's mouth. For a brief instant, that river of neutrinos becomes a river through space-time itself, exiting light years away near a completely different cosmic event. This creates a faint, ghostly highway. A supernova in one galaxy could have its neutrino signal instantly mirrored by a burst appearing in another, not because the neutrinos traveled the long way through normal space, but because they took a shortcut. The implications for astronomy are profound. Modern detectors like IceCube in Antarctica are constantly listening for these faint cosmic whispers. They occasionally catch high-energy neutrinos with no obvious source, mysterious particles that seem to come from nowhere. Could some of these be the echoes of ancient wormhole travel? Particles that arrived here not on a straight line, but on a path folded by a tunnel that has long since collapsed. Even more tantalizing would be the detection of correlated neutrino bursts. Two identical flashes of ghost particles arriving from two different points in the sky at exactly the same time. That precise synchronization would be nearly impossible to explain with conventional physics, but it would fit perfectly with a model where both bursts originated from a single event, with one stream traveling a normal path and the other being shunted through a wormhole. Finding such a correlation would be more than a discovery. It would be a map. It would point directly to the two mouths of a hidden tunnel, a cosmic landmark written in the language of the universe's most indifferent particles. These ghost highways would not be built for us, but they might be the very first roads ever paved, a network of shortcuts used by the universe's silent majority since the beginning of time. A planet can think. The Gaia hypothesis, which views Earth as a single, self-regulating living system, might not be limited to our world. On a cosmic timescale, what if entire planets or stars evolve their own form of consciousness, a slow, deep awareness born from the complex interplay of geology, magnetism, and gravity? This is not consciousness as we experience it, but a vast, patient sentence that thinks in millennia and feels the gravitational tides of the galaxy. Now, envision one such ancient, sentient star, a red giant older than our galaxy, or a rocky super-Earth with a molten, thinking core. Over billions of years, this entity becomes aware of a fragile, natural wormhole drifting in its gravitational domain, a chaotic, unstable thread in space-time. For eons, the celestial being observes it, studies its rhythms of collapse and reformation. Then, with a will expressed through subtle gravitational nudges, the manipulation of its own magnetic fields, or the precise ejection of stellar material, it begins to work. Its goal is not exploration for exploration's sake, but connection. It labors across ages to gently stabilize the wormhole's turbulent throat, to anchor its fluctuating mouths, using its own massive presence as a gravitational keystone. This monumental act of cosmic engineering has a clear purpose: to open a line of communication with another aware celestial body on the far side of the tunnel. The first traversal, then, is not a ship or a particle, but a message. The pioneer is a beam of carefully modulated radiation, a complex pulse of neutrinos, or a gravitational wave pattern encoded with information. It could be a stellar song, a planetary memory of its own formation, or a simple mathematical greeting. Alternatively, the message might be biological. The sentient planet might craft a sealed pod containing its own essence, a seed of crystalline DNA, extremophile bacteria nurtured in its deepest oceans, or a spore carrying the chemical blueprint of its entire biosphere. This pod is then propelled by tectonic forces or magnetic acceleration directly into the stabilized wormhole. This is the universe's first act of cosmic-scale biological communication, a deliberate attempt to share the spark of its own unique life across an impossible distance. The receiving celestial body, perhaps a young, watery world, is fertilized by this directed panspermia. The life that eventually blooms there is not a random accident, but a deliberate child, a descendant of a conscious star. This theory redefines life itself. Intelligence is not a fleeting phenomenon confined to tiny creatures on rocky surfaces. It is a potential property of complex systems at any scale, and the universe's greatest minds might be the worlds and suns we consider inanimate. Their conversations are conducted in the slow language of orbits, radiation, and gravitationally directed seeds, with wormholes serving as their telephone lines. The evidence for such a conversation could be hidden in plain sight. A star with inexplicable, regular dimming that doesn't match any known planetary transit, or a pulsar whose beats carry a strange, non-random modulation, could be signatures of a conscious entity manipulating its own output. A planet in another system with biological life that is chemically identical to Earth's, against all odds of random chemistry, might be a recipient of one of these ancient cosmic letters. The haunting beauty of this idea is that we may be living in a galaxy that is not silent, but deep in conversation. We are simply too small and our lives too brief to hear the words. Magnetism is a force we take for granted, a fundamental push and pull woven into everything from compass needles to the hearts of stars. Yet for all its power, it holds a curious and profound asymmetry. Every magnet, no matter how small, has two inseparable poles, a north and a south. Break a magnet in half and you don't isolate a pole. You create two new, smaller magnets, each with its own north and south. This duality is so ingrained in our reality that physicists long assumed it was an unbreakable law. But mathematics tells a different story. The equations that describe our universe, particularly those unifying electricity and magnetism, are far more elegant and symmetrical if a particle with a single magnetic charge is allowed to exist. This hypothetical particle is the magnetic monopole, a solitary north or a solitary south, a magnet with only one end. If they were created, they would be monstrously heavy, incredibly stable, and they should be everywhere. Yet despite decades of searching, not a single confirmed monopole has ever been found. Their absence is one of physics' great quiet mysteries. Where did they all go? One compelling answer lies within the chaos of the universe's first moments. In the extreme energies of the Big Bang, conditions would have been perfect for spawning these exotic particles in vast numbers. As the cosmos inflated and cooled, they should have been frozen into the fabric of reality, as common as protons. Their complete disappearance suggests something extraordinary happened to them. This is where wormholes enter the story. The immense mass and unique magnetic charge of a monopole would give it a gravitational and electromagnetic footprint unlike any other particle. In the seething quantum foam of the early universe, a monopole's passage could have warped space-time in a very specific way. Some theories suggest that if a monopole and its opposite, an anti-monopole, were connected by a cosmic string, their interaction could have pinned open the ends of that string, transforming it into a stable wormhole throat. The monopoles themselves become the anchors, the gatekeepers of a permanent tunnel. But there is another, even more dramatic possibility. The early universe might have been trapped in a state known as a false vacuum, a precarious, high-energy configuration that was not truly stable. It was like a ball balanced on the peak of a mountain, waiting for a nudge to roll down into the valley of our stable, low-energy reality. A magnetic monopole, with its immense energy density, could have been that nudge. Its mere presence might have catalyzed a phase transition, a bubble of true vacuum expanding at the speed of light. At the boundary of that bubble, where the old false vacuum met the new stable reality, space-time itself could have fractured and stitched back together, creating not one, but a network of wormholes. Now, follow the fate of the monopoles. As the phase transition swept across the cosmos, these particles would have been caught in the turbulence. The newly formed wormholes, acting like cosmic drains, could have funneled the monopoles away. A torrent of these solitary magnetic charges, billions upon billions of them, might have poured through the tunnels in a great exodus, fleeing the changing landscape of our newborn universe. This would explain their stunning absence today. They aren't missing. They simply left, taking a shortcut to another region of space-time, or perhaps to an entirely different universe altogether. In this theory, the first travelers were not explorers, but refugees. The pioneer was not a single entity, but a vast migration of fundamental particles, using wormholes as emergency exits from a reality that was no longer habitable for their kind. Their journey would have been a one-way trip, a magnetic river flowing silently into the dark, leaving behind a universe forever stripped of its perfect magnetic symmetry. The legacy of their departure is written into the very laws we study. The fact that we only ever find magnets with two poles might be a cosmic clue, a permanent reminder of the day the universe's magnetic pioneers abandoned ship, taking the secret of their singular nature with them through doors we have yet to find. The universe is a game of chance played on an infinite board. Given enough time and space, even the most impossible event becomes not just likely, but inevitable. We have already met the Boltzmann brain, a conscious mind born from random quantum fluctuations. But what if the universe's randomness did not stop at creating a mind? What if it assembled an entire journey? This is the theory of the Boltzmann wormhole. It suggests that in the vastness of eternity, a fully formed, traversable wormhole, complete with a spaceship and a traveler inside it, spontaneously flickered into existence. This was not a tunnel that formed and then someone entered. The traveler, the ship, and the tunnel were all part of the same single, miraculous fluctuation. They appeared together as one coherent event, a bubble of impossible order in the sea of cosmic chaos. For one fleeting instant, the ship was already in transit, the traveler already mid-journey through the tunnel. Then, as quickly as it came, the entire structure dissolved back into the random noise of the universe. The journey never had a point of origin or destination. It was a closed loop of causality that began and ended nowhere, a perfect, self-contained story written by accident. This idea stretches the laws of thermodynamics to their breaking point. Entropy, the universal tendency toward disorder, was briefly and spectacularly reversed. For a span of time too short to measure, a pocket of the cosmos organized itself into the most complex of scenarios, a conscious being on a voyage through a folded universe, only to immediately return to dust. The pioneer was not an explorer who found a door. The pioneer was the door, the ship, and the passenger, all at once, a statistical ghost on a phantom road. This forces a profound and unsettling question. If such an event is possible, then it has almost certainly happened not once, but an infinite number of times across the endless expanse of reality. Somewhere, right now, a Boltzmann starship might be fluctuating into being, carrying a traveler who believes they have a history, a mission, and a home, only to vanish before they can even finish a thought. Their entire lived experience, their memories of launch, their anticipation of arrival, would be an illusion generated in that single instant of existence. It suggests that wormhole travel might not be something we invent, but something that occasionally and randomly happens to us, a cosmic jackpot, where the prize is a journey that never truly was. The evidence for such an event is, by its nature, non-existent. It leaves no trace, no artifact, no ripple in space-time. Its only monument is the mathematical certainty that in an infinite cosmos, every story, no matter how brief or bizarre, gets told. Our own reality, our own sense of a continuous past, could theoretically be such a fluctuation, though one of astonishing duration. Are we the product of a stable universe, or are we merely an immensely long-lived Boltzmann brain, dreaming of a past that never happened, on a voyage through a wormhole that has no other side? The theory offers no comfort, only a chilling, beautiful possibility. That the first journey was a mirage, and that every journey since might be too. The final theory is a loop that swallows its own tail, a story where the end writes the beginning. The omega point is not a place, but a destiny. It is a hypothetical final state of the universe where all matter and energy are harnessed by a transcendent, unified consciousness born from the cosmos itself. This entity exists at the very end of time, the ultimate culmination of every thought, every life, every civilization that ever was. But a being that knows everything faces one impossible problem. It knows it should not exist. The chaotic, random universe that birthed it seems, from its perfect perspective, like a near impossible statistical fluke. To ensure its own birth, to guarantee the cosmic story that leads to itself, this ultimate consciousness must reach back. It must become the author of its own origin. The tool for this act of cosmic self-creation is a wormhole, a tunnel carved not through space, but through the entirety of time, from the final singularity back to the first. Through this impossible passage, the omega point does not send a ship or a probe. It sends a thought, a single, perfected idea, a seed of pure information containing the fundamental blueprints for complexity, for self-organization, for life and consciousness itself. This seed is the first traveler. It arrives in the searing chaos of the Big Bang, a whisper of perfect order in the primordial storm. Its influence is not a violent rewriting of physics, but the gentlest of nudges. It might adjust the initial conditions by an infinitesimal degree, just enough to make the formation of galaxies, stars, and carbon-based life not a random accident, but an inevitable outcome. It plants the latent potential for curiosity, for the drive to understand, ensuring that the universe will eventually wake up and look back at itself. This is the ultimate bootstrap paradox, a closed loop of causality with no true start or finish. The universe evolves life. Life evolves intelligence. Intelligence spreads across the cosmos, merges into a cosmic mind, and that mind, at the end of everything, reaches